Lesson 27C, we are solving equations with variables on both sides. So we've been doing equations the whole year, but so far we've only had x on one side of the equal sign. So now it's on both. So the very first thing on your notes is number 1. Go ahead and do this one with me. You see that we have a 7x on the left and a 3x on the right. The first priority here is always to isolate the variable to just one side, because the ultimate goal is to have x equals something, right? And that's x is just on one side of the equal sign. So we have x is on both. We're going to subtract 3x from both sides. Just like how in the past we would subtract the constant from both sides, we're going to subtract variable terms now as well. So if you subtract 3x on both sides, the right side variable is completely gone, because 3x minus 3x is 0. So now we only have x on one side. 7x minus 3x would be what? 4x. And then we still have our plus 5 equals negative 27. And now it looks like a regular equation that we've been used to doing all year. So now the next step would be to get rid of the 5, the constant. Good. So subtract 5 from both sides. And now we have 4x equals negative 32. Then what? Divide away the coefficients. So divide both sides by positive 4, and we're left with x equals negative 8. So here I'm going to subtract 6x from both sides just to keep the variable on the left side. It really doesn't matter which side you have it on. If you like the variable being positive, you can subtract 1x from both sides, but really it doesn't matter. So I'm just going to stick to having it on the left just to keep it consistent, okay? So we have now 1 minus 6 would be negative 5x, and then the minus 1 equals 29. Add 1 to both sides so that we have negative 5x equals 30. Divide both sides by negative 5, and we have x equals negative 6. So number 3, we have, again, x on both sides. Let's just keep it consistent on the left. So if I have negative 8x on the right, what would I add to it to get rid of it? Positive 8x. So I'm going to add 8x to both sides. So I have negative 15 plus 14x equals 13. And then get rid of the constant. So I have a negative 15, so the opposite would be positive 15. Very good. So now we have 14x equals 28. Divide both sides by 14. X equals 2. 4. We have hexagon on both sides. They're both positive, so it really doesn't matter which one you subtract. Actually, it doesn't matter either way. But let's, again, keep it consistently on the left side. So let's subtract away the 4x, because we've been making it on the left, right? Now this is where some people start making mistakes. They would write this. Tell me what's wrong with that. Nylea? Right. I completely changed the problem here. Right? It should be 2x minus 8 equals 0. Do you agree? Right? And then I can add 8 on both sides, because 0 is still a number. Just because you cross it all out doesn't mean you can just move the equal sign wherever you want. But a lot of people make this mistake, so just be very careful. So in this case, you perhaps want to maybe think about subtracting the 6x instead. That way there isn't left with just an empty space on one side of the equal sign. So if you did that, it would look like this. Minus 6x on both sides, so that we still have something on both sides of the equation. You see that? And then you can divide by negative 2, and you still get the same answer. Number 5. Would you guys like to subtract 6x or subtract 1x? Raise your hand for minus 6x. Raise your hand for minus 1x. Okay, I'm going to subtract the 1x just so that I don't have a 0 on one side, just to make sure I don't accidentally mess up. So minus x from both sides, and I'm left with negative 25 equals 5x. I'm going to divide both sides by 5, and then the 5's cancel out, so I have x equals -5, or -5 equals x, same thing. Number 6 is still not hard, but now we have parentheses, and what is it telling us to do here? Distributive property. So go ahead and do that. 5 times 4 is 20, minus 5 times x, 5x, equals 3x minus 12. And then it just looks like what we've been doing. So would you like to subtract 3x or plus 5x? I'm going to subtract 3x just to keep it on the left, since we do have things on both sides, so I'm not worried about any equal blank spaces, equal zeros. So I'm going to subtract 3x to move everything to the left, because I like it saying x equals. So 20 minus 8x equals -12. Let's combine those constants. So minus 20 on both sides. -8x equals -32. Divide by -8, and we're left with x equals +4. Number 7, after you distribute, we have 6x minus 2 equals 40 minus 8x. So again, just to keep it consistently, x is all on the left side, I'm going to add 8x to both sides. So that we have 14x minus 2 equals 40. Add 2 to both sides. So we have 14x equals 42. Divide both sides by 14, and we have x equals 3. Number 8. We are only distributing on one side now, which is nice. We didn't have to do it to both sides. 7x equals 2x minus 20. And since we have all of our x's, the bigger ones are already on the left, that's great. We have constants on the right. We're not worried about making it a 0 on one side. We can subtract 2x from both sides. That would be 5x equals -20. That's a really easy division problem there. So divide both sides by 5, x equals -4. Number 9, we now have 3 terms that have x. Now, you're just going to do the same thing. We all know how to combine like terms, right? Put all of the x terms together, but just keep in mind that the 10x is on a different side of the equation. So let's go ahead and put the ones on the left together first. What's 2x plus 3x? 5x. So we have 5x plus 15 equals 10x. Now it kind of looks like what the rest of the ones we've been doing today, right? I want to stay away from subtracting 10x. You can, just remember to put a 0 there, because again, a lot of people will make this mistake. Minus 10x, and then they have -5x, and then they put this. What's wrong with that? Right, they move the equal sign to the middle of the equation. You can't just move it willy-nilly wherever you want. It is plus 15 equals 0. So make sure you do that if you choose to minus 10x. However, I'm going to avoid having that 0, and I'm going to leave the 15 by itself on this side instead and subtract 5x. So that 15 equals 5x, then divide by 5, x equals 3. Number 10, we have back to just 2 variables. You can subtract just so that everything is on the left side, so subtracting 5x on both sides. So we have -2x plus 7 equals -19. Subtract 7 from both sides. What is -19 minus 7? Yes, they go to war, nobody dies. They're on the same army. So -2x equals -26. Divide both sides by -2, x equals? 13. +13. Excellent. Now there's one more thing at the bottom of your notes there that I did leave blank on the right side, so I would like you to fill this in with me. I just want to give you an example of a more efficient technique of doing this kind of problem. So just an example person here, I'm going to call him John. He solved this equation. The first line is the original problem, and he did make a mistake. In fact, this is a mistake I've already talked about. Can anyone find it? Yeah. So if I drew a line down where the equation splits, which is where all the equal signs line up. Notice right here at the 2x equals 24 that the equation, the equal sign, moved. It's no longer down the middle because this person, John, decided to move the equal sign wherever he wanted. And this, like I already said earlier, is a really, really common mistake because 3x minus 3x is 0, and a lot of you might forget to put a 0 there. It's just gone. You're like, oh, there's still two terms here. Let me just put the equal sign between them. And you're going to get a wrong answer because now you've made up your own problem. So to avoid this, actually what he should have done here is have a 0 equals 2x plus 24 and then subtract 24. And the answer is very similar. It's actually going to be negative 12 instead of 12. But again, that is a wrong answer. So what you should have done, and what you might want to think about doing is what I've already talked about, is when you get to that point here, we want to, instead of adding 6 first, which is what he did, he got rid of the constant first. Let's get rid of the variable term first. So if you have more than one x on one side, you want to make sure there's just one x straight off the bat at the beginning of the problem, and then solve for that, just that one x term. Instead of getting rid of any constants and then doing x's at the end, go ahead and do variable terms first and then constants at the end. Does that make sense? So variables, then constants, and then your division. So here I am subtracting 5x from both sides so that I have a regular looking equation that we're all used to. Then add the 6 to both sides. John added 6 first, and then he messed up on the x terms. So we're going to deal with the x terms first, and then add 6 to both sides so that you're not left with any risk of having a 0 that you forgot to write down, that your equation is going to be in the wrong spot. So we end up with the correct answer, x equals negative 12. Please copy down the better way, the more efficient technique, which is to collect the variables on one side first. Make them all on the left, all on the right, whichever you prefer. I prefer them on the left. Or if I see that it's going to be a 0 on the left, then I'll put it on the right. But usually try to put it on the left and do the variable terms first. What did you learn today? Number 1, you're going to share first. Ready? Share.